Right, so I'm doing this video for one main purpose actually, or two main purposes, which is one, I've created a template that I'm going to start using as standard from now on. Let me just actually zoom out over here and zoom in a tiny bit. And I've set this up because you can set up templates in VS Code where if I type in template, I get this main template and it will always be the case. But the reason why I do that is because, first of all, I always like to put imports at the top. It's generally standard practice. Secondly, I end up always writing things in scripts, and people tend to do this in scripting languages, mainly like Node.js and Python, JavaScript, where you get the flexibility to do it, but then what happens is you grow your code and it becomes something much bigger. This 20 line project turns into a 2,000 line project, or it goes somewhere else, and then you have to start modularizing it, which, when I say modularize, I mean put your code into like blocks, into functions and classes and so forth. And if you're going to do that, you're probably better off starting with a template. So now my Python code is basically minimum of say 20 lines long. So, and even here at the top, I could put some extra bits, like for example, a string at the top where you might want to describe what your module is, and you might also want to have something like double underscore author. I've seen that a couple of times. Double underscore author equals, and then kind of like, and then double underscore LinkedIn or Twitter, equals and so forth. So there's things like that, but they're just like boilerplate things. But it's quite important when you're building up code. So one is I will always be doing this, I believe, going forwards. Although pretty much you've always seen that anyways. It's more like a templating thing. But the other thing is there is now a third, fourth, and fifth option for using one of these AI types of models, and the latest one that's popped up, at least I saw it pop up the other day in one of the social media platforms, is Claude, and it kind of effectively looks like this. And I'm actually going to go into some code on this because I was looking at someone else's generic code, in a book that was written actually, and I thought one of the things that I want to do, that I used to do a ton of, is interpolation. So I thought I'd just start with something very simple, which is a straight line. So something like this, where if I can get it, I pose this as a question, which is this, and maybe again this is something that might go at the top over here, which is, given XY points, produce a best fit straight line in Python. I can remove the in Python bit because I'm in a Python module, but something like this. And this is pretty like bog standard. And I actually literally just stuck that into Claude. So and those of you who watch other videos, I was using Google Bard previously, which is something like this. So now I'm using Claude. I'm going to appraise it. It's going to have advantages and disadvantages, but one nice advantage, and I noticed this in Bard as well, which is why I started using it a bit more, it's just a tiny bit faster than ChatGPT, and it appears as though Claude is just a tiny bit faster than Bard, and also the code tends to be, well, I've barely used it, so I'm not gonna, I'm gonna reserve judgment, but the code appears, at least initially, to be a little bit better, although I'm not happy about this because it's not using an F string, and I'm going to have to decode that little part of it. So I could actually, so one of the first things I did was, given XY points, produce a best fit line in Python, and it was always going to do an sklearn type thing, or sklearn linear model, for the linear regression. There's other ways of doing this, like numpy and so forth. It didn't offer me an numpy, it's just offered me the one option. So actually wonder, so I'm going to do this, is if I take that and just actually stick exactly the same into Bard, just to be fair, and this isn't a comparison of the two, but I might as well just do this. Here's Bard working away, thinking about it, and I guess we'll get to see the distinction between the two. It's taking its time. I think Claude had finished by now, but this wasn't too long. So I'm going to go with, this is actually a bit nicer. Bard's one, because I never needed to, say, put it into a function. It's also used, I wonder if it's offered multiple methods. No, it's actually only offered the one method, because this was from the question above. So it's only offered the one method, and it's actually telling me to use numpy as NP and then do it this way. So you know, and actually, I think for a straight line best fit, this might be possibly the best way. So what I'm going to do for the meantime to give Claude a chance is to, and we can actually see the speed on this. Can this be done using numpy? I wonder actually if at any point on a previous chat, or it wasn't earlier in this chat, but if at any point in the previous chat, and because we know that large language models do take previous things, but I don't think the chat's related, if I asked the same question and somewhere mentioned sklearn, because if I did, then I'd have effectively prompted it to do that. I mean, and I'm doing this prompting now. Can this be done in numpy? Question mark. There we go. Let's have a look and see the speed of it. And it's actually like here's a little bit faster. So whereas Bard kind of like plonks everything out quite fast, so let's thinks and then plonks, just starts writing. So you sort of like know it's active, which is a bit more comforting for a human. But again, notice it hasn't put this thing into a function. And I could sort of like compare them, I guess, in an attempt to compare them side by side. If I can like shrink one, I'm gonna have to do some shrinking. I wonder if I can shrink this way. I'll shrink it a bit more possibly. Yeah, there we go. If you shrink it enough, then it does. It appears as though Claude has done it in effectively fewer lines of code, but it actually hasn't done, and I was looking for, well, it hasn't put it into a function. So am I going to have to prompt it to put it into a function as well? I kind of want to put everything into function. I don't have to. I can put it in a function myself. But what I will say is use an F string for the print in the print statements. I like to feel I'm a bit useful and I'm not totally overtaken by AI, although I know that's not the case either, because basically I could say put it into a function as well, but I'm going to go and stick into a function. Right, it's totally ignored me. That's a little bit annoying, because it's done m.2. Okay, that's really annoying, but let's just take this anyway. I'm going to take this, and I have got Bard on the side. I could give old ChatGPT a shot as well, but it doesn't matter. Any of these would actually have done. And the first thing I'm going to do is def, and I'm actually going to do best fit. So I'm actually going to take the Bard version of it, which was the best fit line, at least like that. But I'm going to paste in Claude's code. So there we go, paste in the code. And one thing that we have to do with Python, because it relies on the indentation, is this. And the MPs come from numpy. We see that they're not defined because we need to do an import numpy as MP. Right, and then we're all hunky-dory. Now, it's doing the slope this way, m. M is conventionally working out the slope of the straight line, and x dot dot, I wonder what dot dot is there. X is a numpy array. So you become a bit thicker when you start to use code as is and take it as a given. But basically speaking, if we wanted to, it's going to look something like this. Well, I mean, it has to do something like this ultimately. If we've got, I'm thinking here, I mean, this line is like a perfectly straight line, but I don't, hopefully it works for a non-straight line, but if we have like our set of points that kind of like look like this, and then in fact what I'll do is, instead of drawing it like that on the screen, I'm doing all this live, by the way, as well, just so that you've got it all live, so that you know that when I'm flying around, it's because I'm doing bits, working as is. So let me just open up. I think I had it somewhere. No, I don't. LibreOffice Draw. Yeah, I think I'll get open a LibreOffice Draw to get it working. So launching that, and then what I need to do is a whole bunch of little points. So I'll make them a little bit bigger, but copy, paste, let's just have loads of these. I'm just doing scatters basically. That's all it really is. I'm hoping I'm scattering them relatively randomly, although that I know that I'm not. Copy paste. If I just select this entire area, because it all, well, I'll move this one off of that one just for the sake of visuality. Not that they can't, scatter points can't be on top of each other, because they certainly can. But I'll do copy paste just so that I've got loads more points and like stick them there, and then copy paste again. Although I've got like replication there, so maybe I should do a. I wonder if I can do a rotation. I can't. I can shrink them. Can I do a rotation here? No, not off the bat, unless I group them. Doesn't matter anyway. I'm not going to bother grouping, but we get the gist. Like, we've got something like this, which is a scatter plot, and then we would have a line kind of like going down like this, and I'm hoping it's going to do a best fit line, although it looked like it might not be doing that. And just let me make the line thickness a bit thicker, and the color, if I can get colors on here, there we go, sort of like a different color there. So basically that's what it looks like, and what we want to do is we want to get, well, I saw it before, like, here we go. We still want to get this point here. That X is the world's worst X, so let's just do something like arrange, flip. There we go. And that's my nice little X. Bold and purple. There we go. There we go. So we want to get this point over somewhere on the line, anywhere, it doesn't really matter, but we want to get this point here. Let me just change the color because we can't see it now. So we got this green point here, and then we want to get another point on the line over here, and this is standard straight line interpolation, so it'd be a bit like when we've got polynomials and other stuff, it might be a bit of it'll be a bit different, and maybe sklearn is better, we could argue. And certainly on the barred part over here, where I see this, I wonder if the np. Well, okay, this best fit line, it looks like actually it's taking a similar approach but broken it actually onto separate lines. That's all it's done by the looks of it. But ultimately what we have to do one way or another, like if you want to get the slope of the line, you've got to do this delta y here. So again, I will turn it into green and that. So we want this kind of like delta y. And then if I've done it right, oops, Control Z there, click on that, one of these. And Control Z, okay, copy paste. We want our delta x, and so I want to get it over here like this. So we want this dy and we want this dx, and dy by dx is the slope of the line. That's ultimately the calculation that I'm expecting to see. So effectively, all of this calculation over here is actually this delta y. This component here is dy, and like I've blazed over it, sort of like I've glazed over it, but this must be the difference between the y starting point, x dot y must be the initial y and the previous y's, and then the same thing for x. So it would have looked like, but anyway, let me just do the colorings here, and this bit here at the bottom here is now dx, and our slope is dy by dx. So if I just get rid of that and bring this back here, we've effectively computed in our first section, we've computed dy, and in our second section we've computed down below dx. That's what we've done. So without knowing what that dot function actually did, I'm relatively certain that it's doing something like this. Just wanted to move that closer to the line so it's observable. So delta y is the first point, like y naught or if I actually label these. So what I'll do is I'll call this one, because I've effectively got 2 points. We have to put every little component on if we want to get this correct, right, for our nomenclature. So we've got the point of x1, y1, for example, and over here that was our first point, and copy that, paste that, move it right down below. We've got our next point down here, which is x0 and y0, and I really should be using, if I can, somewhere on here, because I know that it does exist, format, text. Really, they are, if I can find the subscripts down below. So that's a subscript, and also format, style, where is it gone, text and subscript. Right, so it actually looks like that, and this is lowercase. I hate the capitalization, but it happens, and I knew that was going to happen. Control Z, Control Z. Let me just copy all of this, because I can cheat, and do that, and change that into a Z, into an X. There we go. Oops, still changing it to a lowercase. Okay, let's try that again and do this. Finally, there we go. So this is x0, y0, and likewise I'm going to change this stuff up at the top to x1, y1, and this delta y is now, if I'll take one of these, but delta y, the actual calculation now literally falls down to being y1 minus, again, the scripting of it, so really annoying. Okay, I'll just go over the script. Y1 minus, it's going to be y0, and all of this, let me just format this back up. Everything from this point on is actually normal case, so text, and just remove the subscript. There we go. Okay, finally we got there. So we got the y0 minus the y1. I'm just going to change this to lower cases just because of the capitalizations, and that's what we're effectively doing. And down here, this is the final completion, which is what is our x. Similarly, it's going to be this distance here across this x1 minus this x0, so it's going to be this distance over here, which is x1 and x0, just like this. And this, so y1 must therefore be on the actual drawing, so literally this y1 over here must actually correspond to this over here. That's kind of like what I'm looking at in this big convolution of things, and this y0 over here, which is the y0 from this position over here, must correspond to all of that in terms of the code. This is how we'd have to build it anyway, whether we made it in the version that looked like Bard, or whether we made it as in the version that looked like Claude, which is the one that's in the code. Both ways, that's what it is. So I'm just going to continue with the code now. So we've got the mathematics. The mathematics is all there. It's right in front of us. We know our delta y, delta x, and we're just going to go and compute it. And that's the equation of a best fit line. And from it, well, in the function, when we do come to run this, so I should want to call best fit line, just like that. It takes no arguments needed. And presumably, if I pressed F5 to run it, all down below in our piece of code down here, so down in this little section, we'll get the answer. So let's just hit an F5 and see what happens. I don't even know what's going to happen. Debug has launched itself. Well, I hope we're going to get a string. We do, so we know that it works. So it's more a case of tidying things up, actually. And oh, I see what it's done here. It's a bit nicer, I guess, m.2f, because it's doing it to two decimal places like this, and the way, I mean, it's quite cute actually. So I think I've learned something. I've seen this kind of thing before. It's quite nice. Just going back to the barred version there. Let's see what the upper version was. Well, actually, yeah, I don't like this dot format part. That's what I didn't like, because it's old-fashioned. That was kind of like Python 2, quite a long time ago. And these large language models are taking things, from A to A. It doesn't mean it wouldn't work, by the way. Work just as well. But I think it's just a bit cleaner using that. And actually, what I would normally have done actually is do something like round, because I like to use a standard function. Just keep life really simple. This to 2 decimal places if I wanted 2 decimal places, but I think I would happily leave this in here because it's quite concise, actually, if anything. So it's got the 2 decimal places and everything else. I could actually ask in particular, and I wonder, because this is just a side note on it, but what does the, oh, here you go, you can specify format like .2f for 2 decimal places. So kind of like says it there. F strings are concise and readable. They were introduced in Python 3.6. So my hunch was that this preceded Python 3.6, and we're on like 3.11 now as a time of writing. So it's using code that was applicable, but several versions ago. 6 to 11 is at least 5 versions old. So about a year old, I think, if not more, maybe even 2 years old. So yeah, we've got a best fit line actually, and I think it's really that simple. I'm just wondering now if we toy with, or one of the things that we could do is our best fit line actually should be taking some arguments, which is the first line and the second line. So something like it might take the x, and actually, and this is to keep it quite simple, x as a list. So it might take a list there and y as another list. Right. We could specify it to np dot. I think that might specify it in the right way. I don't type hint to numpy. No, I'm just wondering what the best way to type hint it is. How to type hint. I should know this to numpy. It's something like np dot something, I think. Oh, there you go, np dot nd array. Okay, I think that would suffice. So keep forgetting that, but there we go. So we're just type hinting here. We could type into a list, but actually we're going to type into np.nd. Why do I say np.nd array? Why don't I say list? I could say list. List is much easier to know, but actually the reason why is because if you imagine that you did have a much bigger thing, then you would like much bigger list, like million data points long. The nd array, the numpy nd array would be better. It's a contiguous block of memory, whereas the Python list is quite flexible. We won't notice it for small things. So anyway, if we were to do that, we might need a function like def populate create lists. So something like that, where we want to create 2 lists. Right, and the reason why I'm creating these 2 lists outside of here, so now our function here is we will want to create lists. Okay, we haven't make numpy dot. There we go, something like that. And what we're going to do is return x and y, which is to numpy. I think we could actually say what we're going to get back, which is we're going to get back a tuple actually. I wonder what naturally what it will show back here. Yeah, tuple ND. Okay, the type hinting kind of like is done for us. So leave it as that. And so we've got these lists here. So we're going to look at these create lists, and what we're going to do now is we've got our x comma y equals create lists, which is very nice. So we're going to get back two lists basically, and then we can feed these two lists whatever we've done. And this is the nice thing about doing this thing in a modular format, is that we can so over here and x and y, we can feed that straight into here. So it's just a little bit clearer. It's modularized. We can have a little muck around with our lists and sort of like return what we want in this little function. And also we could, if we wanted to, sort of like place our create lists module wherever we like, kind of like out of the way, because it's not an important feature, should we say. So it doesn't need to come necessarily even before our best fit line. We could paste it down here at the bottom of the code. So again, that's our choice and semantics and so forth. But anyway, one of the things I wanted to do was just change this one to, say, for example, a 10. So now we haven't got something that's linear. This is 1, 2, 3. That was 1, 2, 3, 4, 5, and this was 2, 4, 6, 8, 10. So it looked just very, very crudely. If I pull up somewhere on this doc, if I was to take this again, it kind of like, our x's were 1, 2, 3, 4, 5. So it's a list, something with a slope of 2 basically on there. And in fact, that's what the calculation is, because we see the calculation down at the bottom. So I was just inferring the calculations from every one across. We were going 2 up. So it actually looked like, where is it on there? I don't want that, although you could have pretty little faces. It was exactly the same thing, but kind of like literally a straight line of points, and I'm drawing a bit so like taller up, but it basically looks something like this. And you know, there's going to be 5 of these points actually in equally spaced, so I haven't drawn that like 100% correct. But if I take this line over here and kind of like just redraw it a little bit, there we go on our line. You know, effectively what we had was this and on each case I should really draw our coordinate system as well. So you know, that's our x and y coordinate system, kind of like there, and I'll do another one for the y-axis. It's kind of like that on our coordinate system. There we go. So we've effectively got the same thing down below over here, like this. And where this best fit line literally goes through the data points. So what I've done now is I've effectively shifted. I've said, well, hey, that's great. That's fantastic. It works over there. But now on this one, over here, if I can move it, I'll move all the points in and I'll move the line. I've just said, I'll just shift one of these and just see if it works or breaks it. So let's just shift this one up to like 10. I moved it out of place, right? So is it going to break our best fit line or whatever because it was doing something else? Is it going to draw something between here and here, because that's no longer a best fit? So I'm just wondering what it will do. Hit F5, run it, and it still says, oh, hold on, let's have a look. Okay, we've got the overwrite over here. We no longer need that because we don't want to overwrite, because this is overwriting what was there. So F5 it now to run it. Now we're literally taking this set of points in, and we see that it goes y equals 0.8, so the slope is slightly less, funnily enough. Oh yeah, it will be, because, sorry, I've moved the x point out to 10, so I've moved it horizontally. So like that last point, instead of moving it this way, I actually moved it this way. So something like that, and presumably our best. And what the question is has it made a best fit go over here? this is one version of my best fit. I'm actually going to copy and paste it, and really, like, is a best fit something like weighted in some way like that? So which one has it done in terms of its calculation? And it's not 100% accurate, obvious actually to me from that. I'd have to actually like literally go through even more on the first principle of the maths. Let's just see if there's a clue somewhere in this. Over here, it uses numpy operations to calculate the slope n and m. Okay. Of the line. Compute the sum of the dot products. X dot y. Okay, yep. So this is a vector multiplication because this is the sum of the dot product. So x dot y will be 1 times 2 plus 2 times 4 plus 3 times 6 and so forth. So it's going to be doing a vector operation. So I think that might be satisfactory in terms of how it is. But anyway, this is a nice thing about doing it, which is we had an answer thrown out before, which was this version over here, and it used a linear regression model. And that's exactly what I'm asking for over here, as in, there's two ways of computing the best fit line or the straight line. Is it the line between the kind of like the first point and the last point? Or is it factoring in and kind of like, in fact, I should actually, I'll copy and paste this again, because is it really, like, you've got 3 lines in a way, something like that is the best fit, sort of like that. So let's just change the colors of them to, like, you know, this light purple here and this other version over here. Let's keep them all purplish pink. There we go. You know, which one of these is the straight line? Broadly no, at least in the diagram with the dots that I've drawn, kind of like where they go. And like this least squares process is finding the minimum distance between any of these points, or at least the line that satisfies the condition that the sum of all of the perpendiculars from these points to the line is at a minimum. That's what the least squares process is doing. And I'm just thinking, like, off the top of my head, is it doing that necessarily in numpy? But one thing that I can do without even going to too much complexity thinking about it is I can just take all of this again, and notice, by the way, it uses the same x and y arrays. I'm going to call them arrays because they are actually arrays here, numpy nd arrays. So it's using the same x and y numpy nd arrays. They're not lists anymore. And so I can make a new function, and basically I can do define best fit line, and I might do something like regress. There we go. Right, so, and this version here, let's docstring it, is going to be something like, and we're going to return over here. And likewise, actually, really, I want this function to return something and not print it, but we'll leave it for now. We'll keep it for now. But we are going to use, let me see if I can copy some code out here. Okay, I'll just put using the linear regression model. So using linear regression, and that's going to come from sklearn linear regression model. So again, I just put my imports at the top. Okay, there we go, using the sklearn linear regression model. And what I can then do is I'm going to have to do, this is the thing, right? It annoys me every single time. The one thing that Python doesn't have that, like, you might have in other languages, actually, although you probably still do the indentation even with the curly brace languages, because it's good practice to do the indentation because it makes the code very readable for users. But the curly brace languages doesn't break the code. In Python, it actually breaks the code. So effectively, I start off with some broken code over here because I do this. And even if I didn't do that, even if I tried to paste it so like over here, the rest of it doesn't get the indentation anyway. So I've got to go do this and tab it all across to make sure that we've got the right level of indentation. And again here, well, we got, oh, this is doing a reshape, funnily enough, but still I'm going to want to take an X in. So I wonder why this hasn't, because what I was actually wondering is why this X is not undefined. I would have expected it to have a squiggly underscore be not undefined because it's not in any scope. And that, again, this is the useful thing about putting things into functions, is that it's in the scope. Well, maybe it's taking it out of here, so it's taking it from the main scope. I don't know. No, it couldn't be because it wouldn't know. So I'm not sure where that actually comes from. But what we do need anyway coming into here is an X. Well, I wonder, because it would throw an error anyway by the time I got to this, but we're going to need an X and a Y. And again, we are going, in fact, I can nick all of this. We could put this into a class, by the way. So we could have put our create lists into a class and then had an X and a Y and called it out that way. But anyway, we've got it that way. But one thing that it does guarantee using the same X and Y's is that we should get the same answers using both methods. So we've got that part of it. Now it's done a reshape and y equals np.array y. Let's have a little think about that one. I'm even wondering why it's done a reshape, but I guess it's had to because of the way it was. I won't go into what reshape means. I will ignore going into what reshape means, but I will nick all of. I think I can take all of these lines of code actually, and so I paste them here, and shift tab this all back one so it's all in the right place. And the reason why I've done that is because we've computed an m, which is the model.coefficient. That's how we get it using the sklearn linear regression module. So that's our slope, and we've got a b, which is, in England, by the way, we use mx plus c. Y equals mx plus c is the formula, but I think American format is y equals mx plus b. So, or a equals mx plus b, or something like that. So anyway, they're using the same notation, so it's fine. I don't actually need a return statement, but really I should be kind of like returning something like m and actually b is what I should return, and I should probably return them on both of the functions. So here I should return, right, if you're doing it properly, m and b, and m and b are going to be, they're both floats, so it's a tuple of any and any, but it's actually a tuple. And I wonder what we were doing before, but it was float, comma, float. I'm just trying to make sure that I get my type hinting in the right format. So this here was tuple any. Okay, so it looks like this. I'm stealing the type hinting from the type hinting. That's a new one, even by my low standards, but it's a tuple of float and float. Right, that's actually what it's going to look like. So we sort of like forced it. It's not an any, it's a float float. And the, if I was doc stringing it right as well, which I could do. So again, that's I should say what the arguments coming into this are. So it's kind of like, the args in this particular case is x, which is numpy. We already know what it is because we've type hinted it very well in the array. Right, it's a numpy ND array is what it is, and likewise y is a numpy. I don't even need to say what they are in that sense. Actually, I'll just put the x the x ordinates and the y. That's actually what it is, and that's what it's going to be in both cases. So like, let's doc string, oops, Control Z, I didn't mean to do that. Copy, paste, a lot of copying and pasting code. NumPy. We see why code does get bigger quite quickly. If you want to do these things properly, return slope, return, so it gives us a tuple. Right, in both cases, that's exactly what we're getting back. So there we go again. So we've got two formulas that basically, we got two functions that basically, we can see the docstring now and what it does. One uses the numpy array, and the other one uses the sklearn linear regression model. We can literally, like, having done this, we're very complete now. So we've got that point, and we can now do a proper side-by-side comparison, because again we can do best fit line regress, and I'm going to modify this one to numpy, so just to differentiate, because there might be other ones, but you can see where we're going, and like when we want to appraise models or compare them or so forth, this is kind of like a better way of doing it. So because we've got everything like lined up now, we're still going to print at this point, so I should just run it, because we're going to get, and we should get two lots of this, hopefully exactly the same, but let's just see. It might not be, actually, so let's just see, because if one's doing the linear regression and the other one is just doing kind of like a straight line fit. So there we go, throws the error. Why is it throwing an error? Unsupported format type. String passed to numpy and the array. What was that? Unsupported format, string. Maybe I can't just do that. Okay, but what I can do here, actually, when I hover over it, that's the min max, but let me hover over M. We can kind of like, or let's get the debugger out, right, and put M in here. Right, we've got 0.8, so it's looking like it's correct, and B. But actually what's happening is, we can see, well, B was okay actually, because B looks like it's just a number, but here is actually a numpy array. So I'm just wondering if I did M0, that might be the first element of it, because it's an array. We just extracting the first element, that should be 0.8, so that might be sufficient. So F5 on that. And it also means the float that was returned back. And yeah, they're exactly the same, so it looks like it is working and is doing what we're thinking, or at least what we described as this, like a linear regression. And like, I don't know what the well, I do kind of like know from this particular drawing, this is going to be roughly the closest one. This line here is going to be roughly the closest to the linear regression, and the reason that I know that is because it's got to have a weighting somewhere higher based on these, and then it's going to be pulled down by this one, but not exactly to this one, because it had a propensity to be this pink line over here. But generally speaking, like we've got a level of comfort that it works two ways. We've now got two models. We can appraise like the speed of the models and other things. If I was to appraise the speed of the models, then I would be going into one of the things would be wrapper functions, but actually what's a little bit when you put the little at on top over here, decorators. I'll be using decorators, so you could see that as well, although I'm not a fan of decorators. I'd rather just create a time it function separately if I was going to do it, so something like def timer time code, So something like this, and then kind of like wrap it in and see like which one's quicker or better, or praise it and so forth. But one of the things that actually does come about is, I think if I was to do, because we got this here, now what we actually get spat back is the slope, right, and the intercept, right, is equal to. So that's actually what's coming back, and we might want to print the slope. In fact, we might want to print an F string that sort of looks like this: the slope, and then the intercept, and then intercept. So we might want to print something like that that comes back. And we're actually going to do this because we get slope and intercept from both of them. We would want to do exactly the same over here, just like this. Let's just take this piece of code over there. The reason why I'm doing it like this is because we can then remove the statements. So this is an equation of a best fit line, but it's actually going to be from this numpy array. So I'm just going to comment this one out because the first one's going to be the, oops, when I do that, I didn't type print. Right, print numpy array method. Right, and then the other one is going to be linear regression method. A nice big mouthful. Linear, and I actually separated this time. There we go. sklearn linear regression method. Right. So these are our two methods. So I've commented out this one, and therefore I should comment out this one. Now we won't get the nice formatting that's going to come about, and also I think that this one's going to pass us back because I've just passed m and not m0. So really, what I actually have to pass back is m0 if I want to get a list coming back. Because remember that this thing here looked like, well, m's not available now, but when we could see it, it was actually a ND array that was actually passed back. So we wanted to take out the only one element that's there, which is the 0th element. So it should look like that, and we're going to get back from our print now. We're going to get our slope, but again, I think, well, now we can actually go back, so we can got that dot, was it 2f? So I think it looked like that. Yeah, it does. And 2f like that. I don't know if I'll start using it or not. I do prefer the round statements. The reason why I prefer the round statement is just a bit clearer, I think. Because basically the round statement is and it's a bit more obvious, and so like when you hover over it, it tells you round a number to a given precision in decimal digits. For the purpose of the print statement, I don't know, it seems a bit clearer. This one's a little bit shorter, so I just don't know if this :.2f is intuitive or not. But let's just run our code now, and I think it will look identical again. So there we go, it's run, and we get slope 0.8. Here we got 0.8, 0.8. I'm very particular about this, 0.80, and here over, and the second one. So this was our numpy array method. We got the 0.8, and our sklearn linear regression method. We got 0.80 on our numpy array method, and in our sklearn method we got 0.8. Even though we did the slope, I did around to 2 decimal places, which is kind of like interesting. But maybe because it just doesn't have a second decimal. So I am going to just make them exactly identical, because if what I do to one, I've got to do to the other one, I guess, because maybe the other one would have also changed like that. So let's just get back. In fact, I'm going to take all of this. If you're a really good coder, it means that you're really lazy and you don't do any typing at all. Although sometimes my moving around takes longer than the actual typing. So I'll leave it like that, so they're exactly identical, and we'll F5 it. And we've got linear regression. We've done it quite deeply, but it's quite useful. I like this. I'm probably going to make another tutorial video, whatever you call it. I'd make these videos for myself as well, because I'm going to use the code myself, and I use linear regressions a lot for like simplistic things, certainly. Like, because you can extrapolate and so forth with a linear regression, it's quite useful, and you can interpolate and extrapolate. But also sometimes the data isn't a straight line, it's a curve. So and that's where basically I know that numpy is going, because numpy is not designed for that. That's what sklearn is designed for, like these higher order things. Numpy is designed for like the kind of like the pure maths of the, well, it's designed for the ND array. That's what numpy is designed for, whereas sklearn, if we even scroll up to it, it would kind of like sklearn is a Python module integrating classic machine learning algos in a tightly knit world and sort of scientific packages. But it basically utilizes numpy. Well, in fact, mostly actually numpy goes into all of these other packages. So numpy goes into matplotlib and Skype. So there's a few ways of doing it in Python. I think I could have done Skype as well and so forth, but I'll keep it with this because this is what was spat out by the large language models. It's good enough. It's relatively fast. We'll do some things. I'm sure we could appraise it or go even quicker. But what we do have is something quite nice. And the one last piece that I'll do is sort of something like this, which is, and you might argue that this is useful or not, but basically let's just define a function, kind of like run. Run the numbers. There we go. And I steal all of this X and I paste it all in here. You could say it's absolutely redundant. I'm quite interested actually in, because there's so much abstraction that you need. Like, do I need to go from the double underscore name equals double underscore main guard idiom down at the bottom, costing me like 5, 6, 7 lines of code, all the way to this main module up at the top, costing me another few lines of code, only to tell myself, take this thing here, this run numbers.numbers, so literally do nothing in my main module, and then jump down here. But the reason why I do this kind of stuff is it modularizes it, because as I think I want to do more and more things, I can break it down. So I might do more things. Quite often I do more things in this main module, and then I'll kind of like export that module down and keep on building and building. It's quite a nice way of doing it, especially if you've got like a path, and some people will know exactly what they're going to do, but if you've got a path of things that you want to do but like not a whole 100% determined, it's a nice way of self-determine and become clear to yourself. So run the numbers, basically it's going to do exactly the same thing. And I'm wondering why it is a tiny bit slow actually, to be fair. And I take this piece of code here, and put some lines between them, F5 just to run it, because everything's a tiny bit of a mess when you're using the command line, as opposed to if you're using an app or tkinter or a web browser to output it. The command line looks a bit like kind of like grimmer. And actually one thing that I did on the previous video was to get colors in on the command line, which was quite nice, but I won't go through that here. I think I'll probably call it a day for going through here, just because it's been let's have a look and see how long it's actually taken. coming up to the hour mark, so quite a lot of talking and things done for something that's relatively well known, shall we say, computing wise. I pulled it out of the large language models, but in a very, very much more complete way, should we say. So I can take this and use it elsewhere quite usefully. But it's more about the structure of the code and testing out actually this new large language model as well, which was Claude. So it kind of like let me down a tiny bit in the code. I think Bard sort of like had what I might perceive to be slightly nicer code. But anyway, that's kind of like what that's what it's done. If you like this, if you've got any comments, I'd be very interested to know your comments on the style of the coding actually. I'm sure without a shadow of a doubt that there's other methods. I don't know if I'm going to say better methods, but certainly other methods for creating best fit lines. By all means, throw that in as well. Definitely like, definitely subscribe, definitely follow, do all of those things, and I think that'll be it. I'm going to wrap up. So yeah, that's another video done.